All right. Good afternoon, ladies and gentlemen. This is Toya Barije from the Solar Foundation. I am the Senior Project Manager on the SolSmart program. Thank you for all tuning in. The purpose of this presentation is a SolSmart permitting and inspection refresher for communities that have already achieved SolSmart designation or are in the process of achieving SolSmart designation. So if you've joined in and your community has not achieved SolSmart designation, please feel free to reach out to me. My contact information will be shared on one of the slides. And just a few housekeeping items. We will be having a Q&A session, a 15-minute Q&A session after Bill Brooks, after his presentation. So if you have any questions, please feel free to include them in the tab, the question tab, or you can directly chat me if you have any pressing questions during his presentation. Bill, next slide, please.
All right, hold on.
All right, so with every presentation we have under SolSmart, we have to mention this disclaimer. So this presentation is part of the SolSmart program, and it is sponsored by the U.S. Department of Energy. So we can go ahead and get started, Bill. I will let you introduce yourself to the audience and take it on.
Okay, thank you, Toya. Can you hear me?
Yes, I can hear you.
All right. Hello, good morning, everyone, and good afternoon. I guess most people are going to be good afternoon. Most of you are on the eastern side of the United States. Happy first full day of fall. Yesterday was the fall equinox, and that's when the sun is directly over the equator. And it's if you're in tune with the need for equality, it is the International Galactic, actually, Earth Equality Day. Everyone on Earth gets a 12-hour day from sunrise to sunset. It's the only 2 days of the year. The spring and autumnal equinoxes are the only 2 days that do that. And so we're all getting equal sunshine today. Well, not necessarily on the ground, but at least up in the air. So this is a little bit of a large picture, but I've been in this field for 32 plus years and been working in the engineering aspects of the technology, as doing training, testing, evaluation, standards, and codes and things like that. I'm on the code making panel for the National Electrical Code. I'm on many of the standards panels for the safety requirements for modules, inverters, mounting systems, and the like. And my main goal and mission in the last 32 years of my career has been to see that photovoltaics has its day and that it gets an opportunity to show what an amazing technology it is and how it can be useful to many, many people. It's not the be-all and end-all. It's not the only resource that we have or can use, but it is certainly probably the most unique of all energy sources, and has a lot of benefits for society, particularly in this day and age where we need electricity so badly. So the SolSmart program, as many of you are probably aware, is a national program that has partners and communities throughout the United States. This is actually not an inclusive list here, but it does give a feel for the understanding that these communities are all over the United States. We're nearing 400 different communities, and that includes counties and other larger regions and things like that. And this training is part of the Technical Assistance Project, which is to help these communities with any technical issues they may have in getting solar energy more involved in their communities. And so to that extent, I hope this is effective. And also just want to make it very clear that I am available to help communities on a case-by-case basis. As you have questions and comments and concerns or confusion over permitting, inspection of PV systems, I've been doing this for decades and hopefully can help if you run into issues and concerns and problems. And this is not necessarily a simple field, but we certainly try to simplify things as best we can to make it useful and effective. So this is going to be a refresher course. Many of you may have already been through a training or are familiar with the website. In fact, since I'm showing my screen, let me see if I can bring up the SolSmart permitting website. And just to make sure that everyone is aware of this permitting website, it's just solsmart.org/permitting. And that is our portal that we use to get information out on this subject. And so everything that I'm talking about today is found on that web portal. And to the extent that there isn't something there that maybe I talked about or whatever, again, feel free to contact Toya or myself, and we will see that you get the information you need. And this goes into the simplified permitting process and the steps, and there's different web pages on each step and all the information that you need for the application for a permit, which is the common thing that most jurisdictions use, and then some type of a site plan and electrical worksheets and all that stuff is here to help people understand what that stuff looks like. So back to this process. Let me get back to our slide here. Well, I guess I am, not that one. Let's go back to this current slide. All right, so let's, just as a review for a simplified permit, the information that we typically need for a permit is going to be some type of an application that a local jurisdiction needs. And each application is slightly different, but they have a lot of commonalities in those permit applications that talk about the project scope, the address, who's going to be installing the equipment, things like that. Any contractor information, identification that's required, things like that. The second would be some type of a site plan that shows the location of the major components on the property. Doesn't necessarily have to be to scale, but nowadays, scaling these drawings is really not much of an issue, and we can show where the solar panels might be on the roof, things like that, as far as compliance with setback requirements and other types of issues that might be necessary. The electrical worksheets basically are standard diagrams. They're just fill-in worksheets. We have these in PDF format that folks can use and apply as they need. And it talks about the required signs and overcurrent protection, things like that. And then there's going to be typically specification sheets and installation documents for the pieces of equipment. That might include the PV modules, if there are DC converters, inverters, mounting systems, and the like. And so all that information typically is part of the permitting package. And in this COVID era, it's no longer difficult to talk about electronic submittals because many communities have adopted electronic submittals. If they hadn't already had them in place prior to COVID, they've probably been working very diligently over the last several months to establish those processes. And those are understandably new processes for many communities. And so understanding how to do that is important, but that's one of the reasons why these resources are all online. And these documents can be all submitted in PDF format, things like that anyone can look at. And it's certainly recommended to do so. And that not only helps consolidate things in one location, but also saves a lot of paper that might be stacked up around the office and all. So there's definitely multiple benefits to that whole process. So the basic limits, I would say, for the average types of systems that we develop these guidelines for were intended initially for a snow load no greater than 60 pounds per square foot and a wind load no greater than 150 miles per hour. That being said, when we look at those loading charts, we see that that covers the vast majority of the United States, with the exception of southern Florida, the Gulf Coast, which has taken a beating the last couple weeks here. Maybe Nantucket on the 150 mile per hour wind regime on the East Coast. Whoops, sorry about that. Over here. And then we have snow loading issues, which can happen along the very northern parts of Maine, Vermont, New Hampshire, Upper Peninsula of Michigan, and a tiny little section of Minnesota. But also in the high elevation, certainly throughout the Rockies and certain other high elevation areas where snow loading could exceed 60 pounds per square foot, like, Mount Washington, Vermont, things like that. So those are higher than the typical, and so our typical diagrams and typical processes would not apply to those special case areas, but we're going to talk about special cases as well today. So again, snow load no greater than 60 pounds per square foot, which is most of the United States, and wind load no greater than 150 miles per hour. And there are likely folks on this call that are from southern Florida, and obviously this basic process was not intended to meet their needs, and that's why we came up with additional items for southern Florida. Wind exposure D, meaning not a wind exposure D, meaning that it's not a waterfront location where we have up to around a mile of open water in front of the home. Obviously, beachfront properties would be exposure D. Very large lakefront properties, Okeechobee would be an example of a large lakefront. And then not on a steep hill. Not a lot of steep hills in Florida, but other parts of the country for sure we have steep hills. And so if somebody has a nice house on top of a hill that has a greater than a 5% grade, then that creates some pressure issues that might need to be engineered. And so we're going to consolidate these things into items that don't require special engineering, and that the engineering that we've done for this process is effective. Also, roof mean height is no greater than 40 feet, and that's the mean height, just as a reminder, is the peak of the roof might be 45 feet, but the average height of the roof is not greater than 40 feet. That's an extremely tall house. Not many houses out there of that height, but that's certainly a limit that we've placed on our process. And then a roof structure meets the IRC, and that there's no structural damage, meaning that there's no deterioration of the structural members due to, say, rain ingression or bug infestations or things like that could cause damage to the structure. So the structure's intact. So this is the member attached requirements. So just I'm going to focus on those. Member attached means that we're actually screwing into the rafters of the trusses of the roof. And this is primarily focused on rooftop applications. And the first item is a setback requirement from the edges of the roof. If there's a 5-inch gap underneath the modules, then there needs to be a 10-inch space between the edge of the modules and the edge of the roof. And that's just a basic, simple requirement that helps us get away from the vortexes that happen on the edge of a roof. Also, the array does not cantilever over the perimeter anchors more than 19 inches. So the perimeter anchors are really the deciding factor of all these calculations that we're using. And those perimeter anchors are called upon to hold up the edge of the array, which will typically have the highest wind loading concerns, as well as in areas where there's snow, the highest snow loading concerns. And so those perimeter anchors become the controlling factor on a lot of the engineering that goes into this process, and that's why we have to define how far the anchors, the rails and all cantilever over the edges of those perimeter anchors. That point being that if you have a 24-inch on center rafter setup, you can go up to 19 inches off of the last rafter, but if you've got to go 20 inches or 22 inches, we're going to say, okay, for this process, you're going to have to go on to that next rafter and attach to that next rafter because now you're putting too much stress on that perimeter anchor. And then the gap between the gap under the modules, no greater than 10 inches. Most systems are around 4 or 5 inches. And then there's gaps between the modules, which is also covered in the building code, typically 1/4 inch on the short and long sides of the module, or an alternative would be if you butted the short sides together to have at least 1/2 inch on the long side. So again, this is a refresher. Many of you may have seen this stuff before. The mounting rail orientation is run typically perpendicular to the rafter trusses. And again, this is for the broad requirements because that makes it, we can actually pick up rafters or trusses wherever we can in that situation, wherever is necessary for the design. And then the anchor spacing perpendicular to the rafters doesn't exceed 4 foot on center. And the adjacent rows are staggered where the rafters are 24 inch on less on center. And we'll see some examples of that. So the staggering arrangement actually makes sure that we attach the array to every single rafter, to separate rafters. And so we share the load on the rafters quite nicely with this, perfectly as good as putting connections on every single rafter. So we spread the load nicely, and that helps us in both the snow and wind loading characteristics. And again, that's for the 60 pounds per square foot, 150 mile per hour wind regime. The upslope, downslope anchor spacings according to the manufacturer's instructions of the module manufacturers. And so that's important to understand, is that the module manufacturers actually determine how far apart the rails are. So typically the rails are running horizontally across the roof, perpendicular to the rafters or trusses. And the modules then are mounted on top of those perpendicular rails. And then the spacing between those rails, whether there's 2 or 3 rails necessary, depending on the application, the spacing would be according to the manufacturer of the module. So the module might be 5 feet tall, and the module manufacturer may recommend that the rails be placed 1 foot from the from the short edge, I should say. If you're doing it in a portrait manner, 1 foot from the short edge on either end, meaning that the rails would be 3 feet apart, 1 foot in from the edge, and that gives maybe plus or minus 3 or 4 inches. And so the module manufacturer provides that information, and the installer just simply follows that accordingly. And then the anchors that we're putting into the rafters or trusses are typically lag screws. The most common would be 5/16 lag screws with a 2.5 inch embedment. That's about a 4 inch lag screw. And then there are other fastener arrangements that would have structural support, structural information to back up how they're similar to the holding power of a 5/16 lag screw. Okay, so let's talk about design wind speeds above 150 miles per hour, since we probably have folks on the call that are in those areas and are getting reminded of that routinely as we're in right smack in the middle of hurricane season. And at any moment, one of these hurricanes could come along and hit, as they've already hit the Gulf Coast, could hit southern Florida as well. And so we see that the bottom third of Florida, boy, look at that. The Alabama, western Florida area, which just got hammered, is right there. And then, of course, Louisiana, and a lot of the outer, I would call these the barrier islands off of Texas, which have been recently hit as well, are in that above 150 mile an hour wind regime. So if we go to additional high wind load areas, then we're looking for wind load no greater than 180 miles per hour, which I think covers all of southern Florida at the moment. Somebody can set me straight on that if I'm not 100% accurate. Local communities may adopt their own requirements, so that could be different. Anchors installed at 2 foot intervals or less. And so if we have 2 foot on center rafters or trusses, now we're talking about connecting to every rafter or truss. And that's that helps us with the uplift requirements as we get into these massively strong winds. We can distribute the load evenly across the roof with staggering every other row, but giving us that extra withdrawal strength of the lag screws and things like that is nice with attaching to every rafter in that case. And then we don't go over the cantilever over the perimeter anchors more than 6 inches. So now we're going to be a lot more conservative about how we go over the perimeter anchors to really keep that stress down on those perimeter anchors that are so exposed to those winds. Now we're going to bring the roof mean height down to 30 feet rather than 40 feet, which I think would agree with a lot of the housing stock in southern Florida. We keep our houses low, and that helps keep them out of the wind. And if you had a house that had a 40-foot roof mean height, they probably have a lot of money, and they can probably hire an engineer to do that stuff for them. We're trying to make things straightforward and simple for folks that live in a suburban environment, and their exposure is typically exposure B is really what we're focused on, because it's in a community, and that provides additional protection. And then the modules are in zone 1 of the roof. Now, zone 1 meaning that for a typical roof that's on a house that's less than 50 foot on each dimension, that would be a 3-foot setback from the edges of the roof. And that 3-foot setback, as many of you are aware, is consistent with some of the setback requirements that are in the residential code for firefighters. And in fact, that 3 feet setback for firefighters, it was developed. I was the author of that, actually, and I was one of the reasons how I sold that was that it would cause the modules to be moved to zone 1 of the roof in general, and there are places on the East Coast, particularly Florida, Outer Banks, and places like that, where being in zone 1 is a necessity and a requirement. So a little bit of summary on 180 mile per hour wind regime. Houses that are built in compliance with the building structural codes can support PV. Don't have to have an additional structural engineer involved as long as the structure has not been altered. Anchors installed at 2 foot or less intervals meet the structural code requirements. That represents most of the housing stock in these areas. And then the anchor cantilever no greater than 6 inches, and the modules mounted in zone 1. Now, on the flip side, there are options for low snow load and low wind load areas. So we have the high wind load areas, which would be the extremes on that end, and then we have the low wind load and low snow load areas. And so that looks a little bit different. And this is kind of a gross graph, but it's close to accurate. If you know the specifics of your area and you think my lines are a little off, I drew these lines somewhat freehand. And so, but the blue line says that anything below that blue line has a 10 pound per square foot snow load or less. So that would be the southeastern United States. And then anything below the green line would be a 0 pounds per square foot snow load. But you'll notice that the 0 pound per square foot snow load in southern Georgia, Florida, southern Louisiana, and southeast Texas also coincides with high wind loads. And so since it coincides with high wind loads, those are not simple in those regions. And that's one of the reasons we're chatting today. However, if you're in, Arkansas, northeastern Texas, the northern half of Mississippi, Alabama, Georgia area, then you're in a low snow load, low wind load area, and then the high wind loads at 120 miles per hour pick up, of course, as you get closer to the eastern seaboard and along the Gulf Coast. And as you'll notice, southern New Mexico, southern Arizona, and the western half of California are in a 0 snow load area, with the exceptions of some high elevations that may sneak in there. And those would be considered case study areas, which are the little purple ovals and stuff like that. Case study areas are omitted from these basic lines. So that's just to give people an idea of low snow load, low wind load areas, and those reduced requirements accordingly are in the guidelines and talk about the mounting rails do not have to be, can be they don't have to be perpendicular to the rafters. They can be parallel to the rafters. The spacings don't have to be staggered row to row. They can actually be on the same rafter, which makes it easier. You don't have to find as many rafters on the roof, things like that. And that with a zero snow load and 120 mile per hour less wind regime, we can actually go to 6 foot on center spacing. So that's why California is very interested in that, since there's a lot of solar in California. Of course, southern New Mexico and southern Arizona would fall under that as well. The electrical part of the game is somewhat unchanged from the standpoint of where we are in the country. The biggest changes or the biggest issues that differ from community to community throughout the United States on the electrical side might be the version of the National Electrical Code that we may be adopting, that may be adopted in a particular region, and the temperatures of that area. Those are going to be the two things that are probably unique. However, the basic requirements, things like the electrical components being listed devices like modules, converters, inverters, these things all have specific listings for PV systems. The mounting systems in this simplified process, we're going to say all the mounting systems should be UL 2703 certified for bonding and grounding. That makes it really easy for the installer to do the right thing. It makes it easy for the inspector to inspect the right thing. However, if the array components are using UL 2703 grounding devices, and those devices are being used according to the installation instructions, that would be an alternative. It's just a little more complicated maybe to check out and make sure that those things are being used properly. Third item is the array consists of no more than 2 series strings per inverter input, and there's no more than 4 series strings overall per inverter. Most inverters out there today would meet that particular requirement, and so we'll see. We're going to show some examples in a minute. Field install array, the exposed wiring is going to be a minimum of 12 gauge PV wire, and all your source circuit wiring in raceways would be a minimum of 12 gauge THWN-2 would be the most common, or it could be XHHW-2 or RHW-2. PV wires typically also rated RHW-2, so somebody could take PV wire without any terminations or connectors in it and take that directly from the array to the inverter, which many installers do to reduce the number of connections and improve reliability a little bit. And the PV system circuits on buildings meet the requirements for controlled conductors. 690.12 talks about rapid shutdown. So many of you may be familiar with rapid shutdown, and so typically our rooftop systems are going to employ DC converters, microinverters, or some other type of switch technology that actually enables firefighters to turn the array off if necessary. And that's a fairly new requirement in the code and is intended primarily for safety of firefighters, but it certainly helps other folks as well. Total inverter capacity, no more than 15 kilowatts. And I just give you some weird numbers there to help you read and think about why you have any maximum numbers and what those maximum numbers relate to. And it has to do with our the panel boards in our houses and things like that, and the maximums that are typically available, and those maximums could be quite a bit smaller than 15 kilowatts depending on the size of our service and things like that. So that's, and then we're going to talk about, we'll just do a quick review of some of the standard electrical diagrams in our case studies that we're going to use. So let's do a couple of case studies, and then once we've had a chance to go through that, as Toya said, I'm here to answer questions. I've been doing this kind of training for over 22 years in California alone. I came from, I was at the North Carolina Solar Center, graduated from undergrad and my master's science degree from North Carolina State University. I'm very familiar with hurricanes. I've lived through some hurricanes, very familiar with lightning, very familiar with a lot of things that are common on the East Coast that are uncommon on the West Coast. And now I've become very familiar with wildfires as a wildfire passed through my neighborhood not 1 month ago and burned everything except for my house. And several of my neighbors' houses, fortunately, but several of my neighbors also lost their houses. And that, I can tell you, is more frightening than a hurricane. I don't know why, but it is. Been through both. I'll pick the hurricane every time. So anyway, but let's go back to talking about examples. And we're going to give an example of a 7.6 kilowatt DC converter PV system. And what that means is that the modules are going to have a DC converter on each module, and that DC converter is used for a variety of things and can tell us telemetry about the modules, but it also allows us to turn the module off. And it has some benefits from a performance point of view and various other things. And so 7.6 kilowatts is an important number, which is roughly about half the number that I gave you before on 15 kilowatts. And 7.6 kilowatts is the largest inverter we can put on the load side of a 200 amp panel. 15 kilowatts would be the largest system we could put on the load side of a 400 amp service panel. Not a lot of folks out there have 400 amp service panels, except for rich people. But 200 amp service panels are very common, particularly in Florida and the East Coast, where air conditioning is critical for survival. I know all about humidity. And the mounting systems, we're just gonna, this is a fictitious mounting system. All these names are fictitious, just so we don't get in trouble with folks. But it's an OmniRack system. Now, in this case, it says a sheathing attached. In this case, I'm not sure. We'll see. If it's sheathing attached, we're not going to be able to go up to those really high wind speeds because structural attachment through the rafters and trusses is going to be necessary if we're going to go over 150 miles per hour. But let's say the house was built in 1988, comp shingle roof. And so here we go. And this would be a sheathing attached system. Oh, no, it's not. This is a member attached system. I apologize for that. That last slide has a typo in it. This would be an example of a member attached system in a very high wind area, up to 180 miles per hour. So now we see that the rails are mounted roughly about 3 feet apart. The little dots that you see here are at the rafter or truss connection points, and that every single rafter, the rails are going to typically run, as I said, east-west or perpendicular to the rafters, going crossways on the roof. And in this particular arrangement, there's going to be 4 rails. We're not showing the rails, we're just showing the attachments just so it doesn't get too busy there. The attachments are really the important part and to focus on from a wind loading point of view. And we also said that we can't go more than 6 inches cantilever over the end. So you'll notice that this, the right end of this, which would be the eastern end of the array, cantilevered probably, let's say, about a foot over the last anchor. That would be unacceptable in a 180 mile per hour wind regime, and so we're going to continue the rail out and get to that next rafter, which would be right before the final rafter on the end of the building. And so we're attaching to essentially every single rafter on the roof with this arrangement. And this arrangement would be able to satisfy, if the house was built to meet the requirements and there was no structural damage, this system will survive as good as anything in a hurricane. Let's see. There may be a few other things I want to talk about there. Hang on. I'm trying to back up. There we go. It wasn't backing up for me there. Now it is. Okay. So over here on the structural notes, it talks about the details of this. The mean roof height's lower than 30 feet, things like that. The roof deck is going to be a minimum of 7/16 oriented strand board, maybe even higher than that. Dwellings and wind exposure B. So this gives us all the details of that system, and then we're using 5/16 slag screws with 2.5-inch embedment. We've got a total of 24 modules with DC converters. We've got a string of 13 and 12 converters on the existing roof because those things can take different numbers in series, and so that works just fine. Then we come off the roof with these 2 DC circuits, go to the inverter and combiner. Well, it's actually just straight into the inverter. Any combining goes on in the inverter, and then that goes on to the main electrical panel for the house. So again, this would be a typical Southern Florida installation, needing no additional structural engineering, by the way. This is run-of-the-mill, meets the requirements, and works every time if you do it like this. Okay, so let's talk about the electrical diagram. We got the module called out. We've got the converter called out. It shows that we've got a string of 13, a string of 12. There's no RSD switch in this because it's not necessary because we have these DC-to-DC converters, and it calls out the conductor sizing, 12-gauge conductors coming in, and then our AC going out of the inverter, going to our inverter over current protection device. It's a 40-amp circuit, so it's going to be number 8 conductors going into our main panel, and that's the story. Very straightforward. Here we have the details for the module here, the 360-watt module. The minimum temperature is 5 degrees C here, which is quite warm, and our converter information is shown here. Our inverter information is shown here. The utility, a lot of the utilities in Southern Florida, since we'll use that as an example, require a visible break switch, and the switch that we're using meets that requirement. There's no generation meter requirement. There's only one inverter. Here's the DC disconnect information over here for the maximum voltage and current. And then the AC output current and the other signs that are required according to the National Electrical Code. So that's your electrical diagram and electrical notes page. Now let's do a microinverter example. Hopefully this will help in providing a couple different, very common, these 2 types of systems would be by far the most common, and DC converters and microinverters would make up probably 70% of all installed residential systems in the United States at this time. Those numbers change, fluctuate a little bit, but even more in some areas, maybe less in a few other areas. So let's talk about the microinverter system. This time it's going to be, again, the exact same number of modules, 24 modules. 24 microinverters. Now the microinverter capacity is going to be smaller than the inverter, than the module, because it doesn't have to be of the same rating of the module, because the module really never produces that much power anyway, and there's losses in the inverter and things like that. So don't get too worried about that. The racking system would be attached to the rafters. The maximum span would be 72 inches. That would only be allowed in southern Arizona, New Mexico, and the western half of California. But if we're in southern Florida, where it could be as little as 2 feet on center. Again, this house was built in 1988, comp shingle roof, very low pitch, 4 and 12. Here we see the same type of consideration. Now this is interesting. Hopefully it'll cause some folks to scratch their head and say, is that allowed? Here is a hip roof, very typical of a lot of roofs in southern Florida and areas that are hot, humid areas. Love to have a wraparound porch on something like that, yeah. So nice cool breezes. So hopefully pick up some of those if you're near the water. But here we see that the anchor points are on every single rafter. So this would be designed to be able to handle that 180 mile per hour wind regime. Mean roof height, again, less than 30 feet. And you'll notice that because we overhang on some of these modules, so particularly over here in the southwest corner, I should say, that we're going to actually extend the rail out to the next rafter and pick that up, which will help support those edge anchors, which are the ones that are under the most stress. Now you'll also notice that the north arrow is facing basically up on this page, and so the stuff on the north side of the roof is facing north. But this is a 4/12 pitch, and if you were unaware, the north side of a 4/12 pitch will produce more than 75% of what a south facing 4/12 pitch will produce. Okay, is it as good as the south face? Absolutely not. So that's why more panels are on the south face. But if we needed room, the next best place to go is actually either the north face or the east and west. So it depends on how much room we have. And in this case, the north face provided us a lovely area to put a bunch more panels on, and we could continue putting panels on. Another thing to realize here is that the transaction costs in selling a project to a homeowner and things like that, they're not insignificant. And pulling permits, that's time and money and effort and all that. Solar panels are cheap. And so that's why you're going to notice that a lot of systems, they're going to often maximize out how many solar panels they can actually fit on the roof with the understood limitations of setbacks, and that's where you see all these 3-foot setback lines. Those 3-foot setback lines are to prove not only the firefighter access pathways are sufficient, but also for Zone 1 application, making sure that we're keeping the array in Zone 1, which is far less wind loading. In fact, Zone 3, which would be the corners of the building and the ridge of the building, of the house in this case, has right at twice the wind pressure as 3 feet in from the edge, 3 or 4 feet in from the edge. And so depending on the dimensions of the building, this happens to be a 51-foot building, and so I'm sure some folks on the call are going to go, oh, it's 51 feet, so it's actually more than 3 feet. Correct. Good call, good catch. So the idea is that we stay away from the edges. That reduces our peak pressures to roughly half of what they would be if we decided to go into those areas. That makes it doable in a 180 mile per hour wind regime where it would be just physically impossible. Actually, the glass would blow out of the frames if we were to try to get into that Zone 2 or Zone 3 in southern Florida. So let's just do the quick electrical diagram here. Simpler diagram. We're just talking about one module going into one inverter, and we've got 2 branch circuits, each with 12 inverters on them. And those 12 inverters are each going to a 20 amp circuit breaker that's being combined in a little AC combiner panel, which is number 5 on our list there. We're just going to use a simple, inexpensive 125 amp main lug panel for that, and then we're going to go through an AC disconnect, since a lot of our we're not going to have a generation meter, but an AC disconnect, and then because our utility might require it in Florida, and then go into a 40 amp circuit breaker and a 200 amp panel. The manufacturer cable is going to be used for the stuff going from microinverter to microinverter, because that's a microinverter circuit. And then once we go to a junction box up on a roof, we're going to transition to 12 gauge conductors and then go on from there. And then coming out of the AC combiner panel, we're going to upgrade to 8 gauge conductors for the 40 amp circuit breaker. So very similar to the previous design. So very common. Literally, these 2 designs that I'm showing you today have been done on the order of 100,000 times in the United States each. 100,000 are these virtually identical to this in every single way. So it's a very common, very, very, very common installation. Here's our modules and inverter, microinverter characteristics. We don't have to have a DC power source sign. We just have the AC one and the other signs related to rapid shutdown. And if we've got, we're going to supply multiple sources into our main panel. Alrighty, so that's a refresher on the permitting side. Again, I'm here and available to help in whatever way possible. So let's push on to talk about inspections, and I'm just going to hit a few of the high spots, and then we're going to open it up for some questions. I know you're living on Zoom and WebEx and Teams and all the other crazy formats that people have developed through COVID-19, and so if we can give back a few minutes of your time today, great, but I want to answer everyone's questions, and I want to have plenty of time to answer questions and concerns, and if there's issues that are just problematic. Pretty much run into everything that can be run into in this field, and happy to talk these things through, help jurisdictions and installers get to solutions that can get more solar panels and more solar systems installed. That's my goal in life, at least. So let's talk about the inspection side of things. Again, these documents are available on the permitting website, and it's just a little one-page checklist, and I'm just going to pull a few items off that checklist. So normally when we're doing inspection, we start with the system that's fully installed, all the disconnects are off. Now this is showing the disconnects in the on position because presumably this system, in fact, it had been inspected and permitted and was given the permission to operate, but normally those switches would be in the off position, which would be down. So, sorry, a little WebEx thing is being pain. Let's see. All right. The first item on my list I've done a lot of these inspection checklists over the years, dozens of them, in fact. And kind of one of the things that has risen to the surface as being probably the most commonly messed up process, and maybe the most important process in an inspection, is that the National Electrical Code requires that all work be done in a neat and workmanlike manner. Now, that's not a sexist term, although some folks would like to change that term. It just means that the workmanship, which is not gender related, is done well, and it is clean. It is there's not wires hanging all over the place that could capture debris, conductors hanging down. So when you look up underneath this array, you basically see blue sky. You don't see a bunch of wires hanging down that are ugly and things like that. You're going to see the anchor points clearly because it's got to attach to the roof. But I like what I tell folks is that I want this technology to look like wireless technology. Like, you got to scratch your head and think about how in the world did they get the electrical from the roof down to the inverter. And if it's difficult to figure that out because it's so clean, that's a really nice installation. And that gives a really good impression not only to the homeowner, but also to the inspector. And it's easier to inspect. We're also going to look at making sure that the model number and the number of modules that are installed match up with the permitting that was done. So a lot of the permitting nowadays is being done through electronically as submittals. And so the only people that are actually going to physically see this thing, of course, are going to be the field inspectors, and they're verifying that what's submitted online is actually what was placed in the field. So the field inspection part of the process is very, very important. And so we don't want to underestimate that. But it wants to look clean and neat and match the approved plans. And you're going to see the numbers don't match up here because I've skipped a few things and just kind of hitting the high spots. the cable support, making sure that the cables are not hanging down, really, really important part of the process, particularly in high wind load areas where that high wind can really abrade conductors rapidly if they're not well supported and well held in place. Now we're getting to see the ugly side of this, which is not visible from anywhere except for the ridge of the roof, but it is done reasonably well, and you'll notice from the ground that you can't see any of these wires. And the good news here is you'll notice right across the street there's another solar project on that, and this neighborhood probably has a dozen solar systems on it because this was done very neatly and cleanly. And the neighbors said, hey, you know, that's saving you a lot of money on your electric bill. I think I want to get in on that. There is going to be a rush, by the way, of projects over the next year or two because the tax credits are threatening to be removed again. They're sunsetting. So unless Congress actually extends them, then the rebate or the tax credits for residential are going to sunset in another year and a half or so. And because of that, there's going to be a lot of activity in the residential sector. So good timing for this training, and hopefully you're going to see, as we come out of COVID, a lot of projects going in. The equipment listings are important, and so making sure the listing labels are available. Now, the listing labels on a PV module, like up in the top left corner, are generally not visible very easily because they're up underneath the panel. And so normally what I like to do is, for my inspectors, is to take a picture of that listing label for them and show it to them so they can easily inspect it at ground level or even up on the roof if they want to get up on the roof. But they don't have to go to heroic means to get a view of that listing label. And if they, for whatever reason, they want a direct shot of it, I'm happy to help them out and get a picture of it. Front-facing cameras are very good at doing that, and so that technology really helps us a lot in inspections as well. So inverters and modules and DC converters and microinverters all have listing labels on them that we want to confirm, make sure that we're using approved equipment. Another point on approved equipment is that we do have a thing called the internet, which we're working over right now. And I can go on the internet today. I can go to Amazon.com. You might have heard of that little organization. I can go to Amazon.com and I can buy just about anything for just about anything. And sometimes it's got the proper listings that the National Electrical Code requires, and many times they do not. So the availability of products that are not properly listed for code approval, for the electrical code approval, is quite a large group and quite easy to obtain by Thursday of next week. And some of them by Thursday of tomorrow. So the point being that the listing process is very important, and checking to see that products are properly listed and all that is important. And that issue has gotten more important rather than less important with the proliferation and the ease of sourcing some of this equipment. It doesn't mean the equipment's unsafe if it doesn't have the listing. It just doesn't. It means that it doesn't comply with the National Electrical Code requirements. And so we might use it for our RV or something like that, which wouldn't require National Electrical Code compliance, but we're not going to use it for our house. We're not going to use it mounting on our house, in our house, things like that. Can't do that. It's got to have proper listings in those situations. Disconnects according to approved plans. So many of the inverters actually include the disconnect wiring center as part of it. I'd say most inverters today do. If they don't, then they need to have a separate disconnect, as you see here. Circuit breakers are often the disconnects that are required by the code. But we also mentioned that the AC disconnects in a lot of communities around the country, particularly some in the Southeast, require a separate visible switch like you see here between the inverters and the main panel. Incidentally, the 2020 code requires that these switches, these safety switches, or they're just a 240 volt switch. If you can open them and expose energized parts, then you have to put something that requires a tool to open it. So you can put a nut and bolt through the hasp. There's a hasp on this particular device that would lock the enclosure cover closed. But the concern is that you don't want a 6-year-old kid walking up to this this disconnect, which is the exact same disconnect that are used for air conditioners and stuff like that, and open it up and get their hands in it. We're actually going to see air conditioner disconnects probably follow suit in the 2023 code because it is a hazard and it is a concern. But we've applied it to PV systems, and that's just something to be aware of. You do not want to be able to open a cover of an electrical device that exposes 240 volt or 120 volt parts that a kid could get their hands into. So that's just something to be aware of coming down the road in the electrical code for safety. There's some more of those switches right there in the top middle. PV systems marking label according to approved plans. So we have in our plans the requirements for the signs and the disconnects and things like that. And that's just showing some examples there. And then access in the working space for operation and maintenance of equipment. So the code basically requires that any electrical equipment that requires some type of access and servicing, switching circuit breakers, replacing fuses, things like that, is going to have, according to 110.26, it's going to have a minimum of 30 inches wide, or the width of the equipment, and a minimum of 36 inches back. And so we see in the right-hand picture here, a banana tree has grown up and is blocking access to the service panel as well as the inverter and disconnects. And on the left-hand side, we see that it was not laid out well. We've got a battery system that would require the technician to actually stand in the battery box. Hope they don't sit down. That could be a little exciting. And that would also not be compliant, providing the necessary access. So that's just some examples there. And then lastly, the rapid shutdown system is installed according to the approved plan. What you see here is just a little diagram that shows that this would be a microinverter system or could be a DC optimizer system, both of which we showed you in the process. And we see that when we turn the system, when we turn the rapid shutdown switch to the off position, in this particular case, the circuits leaving the array are essentially de-energized to below 30 volts, and the modules in the array are open circuited to no more than 80 volts. And so the hazard has been dramatically reduced to the firefighter either through DC optimizers or through microinverters. Now the sign I show you here has got a red background to it. In the 2017 code and beyond, if we're going down to this level of voltage, that would have a yellow background. And then because the conductors inside the array have a reduced hazard as well as outside the array. So the yellow background, it looked very similar, and the wording is slightly different. And both of those signs are shown in the 2017 National Electrical Code, as well as the 2020 code only has the sign that's related to the hazard within the array. So there's my email address as well as Toya's email address. We're here available to answer questions, anything you got. And then if something occurs to you after you get off the phone today or after you get off the call today, please let us know. And so let's open it up, Toya. It looks like we've got some questions in the chat area. So let's talk about it.
Yeah, absolutely. We'll just give folks a few minutes to go ahead and get their questions in. So please send in any questions that you have, and I will read them out, and Bill will have an opportunity to answer them.
Right.
Okay, we'll give you about 2 minutes. Bill, that was a really interesting presentation. Thank you so much for sharing your knowledge.
Well, and everyone who's out there in internet land, yeah, just a little bit more on the wildfires that happened here. You probably heard of my little town in California in the last month, Vacaville, California. That's where I live, and not just that town, but the fact is that where I live in that town is exactly where the fire went through. And a good friend of mine from we're in Scouts together. Our sons were in Scouts together. Lost his home and his barn and everything. It's really tragic, but one of the things that this is really focusing people's efforts on, which would include hurricane areas that are really getting beat up this year with storms, is power outages. So we're seeing lots and lots of power outages. We were without power for 10 days here. A lot of power outages due to the hurricanes and tropical storms on the East Coast. And so backup power is a big deal. Lots and lots of generators being used, but a lot of folks that have solar want to be able to use those during power outages because they don't require fuel. Because fuel supplies also can be very, very difficult, particularly things like flooding that comes along with tropical storms. And so energy storage, coordination with generators, all that kind of stuff has become very, very important. And even though these simple guidelines are really not focused on energy storage or generators, just be aware that there are a lot of products that are coming on the market, and so many that are already on the market in this area. And we're happy to help folks that are trying to work through some of those issues, because that is going to become more and more commonplace as the years, as in the next couple of years, that people are going to realize that your typical PV systems are designed for safety to shut down during power outages, but obviously that's exactly the time when we need power, and there are technologies out there that can help us with that, and so we'll see a lot more of those things coming forward. So doesn't look like we're getting a lot of questions, but definitely want to make it clear that we're available to help folks. And don't be shy. We are here, and I really enjoy helping communities and our community partners in getting things so that it's easier for them. That's ultimately what we're trying to do, is reduce the workload. Everyone is stressed with trying to deal with things remotely and over on online situations, and there's a lot of nice online products out there, which we have on our website, but there's also some new exciting stuff called the Solar app that's getting rolled out. And so there's some really nice resources that are there to help communities get through the permitting process, but that's not enough. We also want to make sure they get through the inspection process and bring their inspectors up to speed so they know what they're looking at, and can address any concerns that might occur when we find issues in the field and how to rectify those problems. So there was a question about the Solar app. Yeah, go ahead.
Yeah, exactly. I was just going to say, so on that topic, Laura did have a question about Solar app.
Yeah, thanks, Laura. I appreciate the question. And like I said, I've been doing these permitting guidelines for a couple of decades now, and Solar app is kind of taking it to the next level. And it's a very new process that's really, I would consider it's in beta testing at the moment, and but very, very encouraging. And so it's intended to be a resource to communities that they can opt into it, if you will, and very rigorous on the computational side of things, because basically it's letting the computers do all the work and using databases for modules, inverters, and they're going to include energy storage systems over the next couple of months and all that. So in a lot of ways, it takes a lot of the guesswork out of the process, and really takes it to the next level, if you will. So, PDFs of things that can be filled out are great, but they still require a fair amount of interaction. And this process will essentially automatically generate diagrams and things like that, and help in the process so that it's transparent to all involved in the process. And again, put together some really nice stuff that communities can use with confidence that it's covering the issues that they're concerned about, meets the code requirements, and the like. So I'm a strong supporter on the solar app side of things, which is focused on the permitting side. There also is a lot of work being done on virtual inspection. And so I think that's a follow-up question of Laura's there. And I'm sure the solar app program will include virtual inspection processes as well, but this is much, much broader than solar app. There's actually a new NFPA standard for remote inspections, talking about the kinds of information and photos that would be necessary for a remote inspection to be accomplished. So for obvious reasons, clearly solar projects are not the only thing that need to be inspected in the COVID era. And so this is a struggle that everyone in the field inspection world is dealing with. And so there's a lot of great resources, and there already is in place quite a few nice resources for the solar side of things. And so those processes, I'm sure Solar App will have access to various virtual inspection processes, but there will be a number of different avenues for that particular area that I'm sure communities will be adopting. And the hope with something like a solar app would be that because it's so detailed on the solar side of things, that a community could just simply adopt that virtual inspection process, and they don't have to invent their own or whatever. It would essentially just plug into their existing processes that they're already using for other construction in their communities. But hopefully that will answer some of those questions. Anything else that I missed there, Toya?
I was just going to say in the chat box, I've also added the link to some more information on the solar app for those who are not familiar. So if you go to www.thesolarfoundation.org/solar app, there is some introductory information about what solar app is.
Great. Excellent. Thanks for doing that.
Well, it doesn't look like we have any other questions.
All right. Well, again, as we sign off, you have our email addresses here. More than happy. I spend a good portion of my day helping communities and helping jurisdictions understand questions. In fact, right before getting on the call today, I was communicating with one of my favorite inspectors in the San Diego area that I've for 15 years. And so there to help you guys in any way possible. And we're here for you. And if you have any questions as you get into some of the nitty gritty, which a lot of times during a quick presentation like this, those questions may not come to mind, but we're happy to address them as they come up.
Yep, and just to add also, the webinar was being recorded today, so I will be sending out a link to that recording to attendees and absentees.
Great. Thanks, everybody.
Thank you, Bill. Thanks, everyone.